Hello, and welcome to this webinar on Virtual Factory Standard. Virtual Factory is now available as part of the mainstream innovation platform manufacturing suite. If you're coming from the Solidworks ecosystem, you're already familiar with our powerful modeling tools. Virtual Factory Standard builds on that foundation, providing enhanced capabilities for layout design, whether you're using Solidworks or a similar solution. In today's session, we'll show you how to transform your 2D drawings into immersive 3D environments, helping you visualize and optimize floor space more effectively. We'll start off by first creating a new manufacturing cell. The manufacturing cell is going to act as our top node, containing all the information of the cell we are creating. Think about it like the top-level node of an assembly. When using cloud services, the data you create is saved to a database. To make my life easier in the future, I'm going to change the name of my cell. Now, whenever I need to reopen my model, I can just search Factory Simulation Engineer Webinar. The name change will appear in my tree on the left-hand side of my screen. I have my top-level node, but next I need to establish a location in my model to import my 2D drawing. I use an area resource here to help structure my manufacturing cell into sections. This will act as a container for the DXF file I will import. To import my DXF into the platform, I need to use the Edit Footprint command in my action bar. When selected, this will bring me to a new window that enables me to select the file I will be using. Importing the drawing shouldn't take longer than a couple of seconds. After completed, we can exit the Footprint Edition mode and see the drawing in the manufacturing cell we initially created. Our import tool enables users to bring in a variety of drawing types. It can import DXF files, DWG files, IG2 files, CGM files, and more. Moving forward, I need to place another manufacturing cell resource to act as a container for objects that will be included for visualization and spatial accuracy. These can be visual aids or structural elements, such as fences and pillars. I placed all of my visual aids inside of a bookmark. Think of this bookmark as a quick way to organize data that you intend on reusing over and over again in different kinds of models you are creating. Since I previously modeled and used a fence, beams, and caution mats in another machining line, I stored them in this bookmark for easy reuse. Reusing them is very straightforward. Simply select the object from the bookmark, click Insert, and choose the desired node for placement. The last object I inserted from my bookmark is the caution tape positioned in front of the machines. At the moment, it appears as a plain gray mat because the object material is turned off in my view modes. I can adjust these settings to display elements like individual axis systems or modify the geometry detail level within the frame. Okay, so I have some 3D geometry in my model now. The next step would be to position them in the correct location based on the drawing I imported earlier. There's multiple ways I can move my resource. This first method, I am using something known as the snap command. The snap command allows me to choose a specific point on my resource. Once selected, I can choose another point and move the entire object relative to my next selection. For my fence, I am trying to align the center of this mounting hole with the location on my drawing. Quick layout tools turn 2D drawings into 3D models fast, boosting accuracy, speeding up workflows, and helping teams visualize and refine designs before production. That same snap tool can also be used to align edges and points to other points and edges. Watch how I place the caution mat in front of the machine where it belongs according to the drawing I imported. Alternatively, when I select the object, an orange coordinate system known as the robot appears on the axis. I can use the robot to manipulate the orientation of objects by dragging it by one of the axis systems. In this case, I need to rotate the I-beam 90 degrees so it stands upright. From there, I can just use the snap command again to align the I-beam to the appropriate spot in the drawing. I can see in my drawing that I have multiples of plenty of objects like the I-beams, the caution mats, the fences, and my machines. Like Solidworks, within Virtual Factory Standard, I have a pattern command. The pattern command allows me to create multiple iterations of an object and have an offset distance in where they will be located. The pattern command comes in handy when I need to position an object in various locations. But if I only need one duplicate of an object, I can use the common copy and paste commands. When I paste a copied object, it creates a reference of it, meaning any changes done to the original object will cause the change to occur for all the references. I can now reposition the I-beam to the correct location by simply dragging it by the robot like before. Bear with me as I use the tools shown thus far, so I can position the rest of the caution mats and fencing to align with the drawing. With the caution mats in place, the next step is adding the fences for this. I'm using an advanced layout tool called Smart Snap. To use Smart Snap, the 3D object must have a feature called a connector port. You can think of a connector port as a custom access system that allows two objects to connect or mate with each other. By simply dragging and dropping, Smart Snap links these ports to precisely position the objects. The last thing we need to do is actually import our machine models. Like before, I have started to build a bookmark that contains machine models that exist within my facilities. I am going to pull in a Haas machine and a Tormach. Using the robot, all I am doing is dragging the machine models to align with its position on the drawing. These machine models have every bit of detail down to the nuts and bolts on the machine. The level of detail of your models should not impact the performance and speed of your application. Give me a few minutes so I can finish up our model here. And just like that, we have finished building our 3D model from a 2D drawing. I have clearer visuals and understanding of my space, making it easier to determine what will truly fit within the confines of my facility or cell and can get buy-in from my key stakeholders. If you have any questions or would like to learn more about Virtual Factory Standard, please reach out to your local reseller. Look out for our next video on Virtual Factory Professional to learn how we can actually use these models built to start building your process flow and understanding your system's utilizations, identifying bottlenecks, and optimizing your resources.